All right, in this video, we're going to talk about the fates of pyruvate when oxygen is not present. So here again is the structure of pyruvate. And when oxygen is not present, let's look at what first happens in eukaryotes. Okay, so organisms such as humans. So ultimately what will happen is that pyruvate, let's just write the name here, is going to be converted into lactate. Let's just go ahead and draw the structure of lactate over here. Okay, so this is lactate. And let's just examine what's different between these two compounds. If we were to number the carbons of pyruvate, and here we have the numbers of carbons over here on lactate, you can see that carbon 2 is different. In pyruvate, we have a ketone functional group. In lactate, we have a secondary alcohol. So what's actually happening in this reaction? Well, first off, the enzyme that converts these two is called lactate dehydrogenase. Or LDH, it's often abbreviated as, lactate dehydrogenase, a very, very important enzyme. So in this pathway, what's actually happening is this compound called NADH will be used. So I'm going to draw out the structure of the nicotinamide ring of NADH. And this is something that you probably want to get fairly familiar with. So this is NADH. And I'm drawing it so that it's just positioned right underneath carbon 2. And here's why. Once these two substrates bind to lactate dehydrogenase, the following reaction can be catalyzed. So the lone pair of electrons on nitrogen is going to sort of push around the ring. And what it's going to do, it's going to push off one of these hydrogen with its 2 electrons, like this. Okay, so that hydrogen with its 2 electrons will now react at the carbonyl carbon, and this will pick up a proton from the enzyme, resulting now in the formation of this secondary alcohol. So let me just put a box around that hydrogen and that hydrogen there. So the NADH is literally transferring its hydride, hydrogen with 2 electrons, onto the carbonyl carbon. And the resulting compound that's formed, NADH, is converted into NAD+. Okay, just to remind you, NADH is the reduced form of this molecule, whereas NAD+ is the oxidized form. So this is a redox type reaction, and what's happening in the substrate, carbon number 2 is becoming reduced. So we're adding a hydrogen and we're losing an oxygen bond there. So lactate is more reduced than pyruvate. So the production of this NAD+ ultimately is a very important component of cellular metabolism. And in this next little section, I'll just show you how this is going to help feed back and help glycolysis to continue. All right, so to finish up with our discussion then of what happens in terms of fate of pyruvate, now again, this is in the presence of oxygen. In the last little section, we talked about how pyruvate is ultimately converted into lactate. All right, so I've drawn the little schematic figure that shows the process of glycolysis. And recall that in one of these steps, it's actually this step right here, we're going to utilize NADH. Or I'm sorry, we're going to utilize NAD+, and that's going to be converted to NADH. Okay, so this is the glyceraldehyde 3-phosphate dehydrogenase reaction. So G3P dehydrogenase. So, in order for glycolysis to continue, okay, down to pyruvate, ultimately, we're going to need to have a way to remake or resupply this NAD+ so that we can continue through that reaction right there. So in the absence of oxygen, so when O2 is minus, in eukaryotic systems, the pyruvate cannot go to acetyl-CoA. That would only happen in the presence of oxygen. Instead, it's going to get converted to lactate. And as we just saw in the last video, NADH is used, and it makes NAD+. Again, this is the LDH catalyzed reaction. So look at what happens here. The NADH that's produced in this step can now cycle down and interact with LDH, and likewise the product, the NAD+, will replenish the NAD+ that's needed to keep glycolysis going. So what this little area here is called, this is called the cytosolic NAD+ pool. That's right there. So in order for glycolysis to continue, there has to be a way to replenish that cytosolic NAD+ pool if oxygen is not present. And if LDH is functioning properly, this serves that function. So ultimately, it allows eukaryotic cells to continue a little bit of glycolysis and ultimately making a small amount of ATP, even when oxygen is not present. So this is called lactic acid fermentation, or lactic fermentation. And again, it allows for the replenishment of this NAD+ pool so that glycolysis can continue. All right, so I hope that helps with the fate of pyruvate in eukaryotes when oxygen is minus. Definitely want to get a feel for how this little cycle here connects into glycolysis. Good luck.